Welcome to The Explainer. So, have you ever wanted to just create your own stunning AI-generated art completely from scratch without paying for those crazy expensive subscriptions? Well, today is absolutely your lucky day. Let's just dive right into this explainer. We're going to walk through exactly how you can build a free custom AI image generator in literally just a few minutes using Python. And hey, whether you're a seasoned coding veteran or, someone who's literally never opened a terminal in your life, stick with me. We are going to break down the exact steps to get you up and running. Now, if you're feeling a little intimidated right now, don't be. The creator of this method said it best. It's stupid simple. You don't need to be an expert programmer. I mean, how empowering is that? We're not out here building complex neural networks from absolute scratch today. Instead, we're leveraging some seriously incredible open source tools that require just a handful of lines of code to unlock some massive creative power. This project is highly accessible. Anyone can do this. Just look at the kind of wild, unlimited creative freedom you get when you actually build this yourself. Check out these prompts the creator used to test their code. I mean, you can go from generating a capybara holding a Hello World sign to a super detailed cyberpunk characters standing in a rainy alley to a Roman soldier guarding a coliseum. You can even conjure up the mythical image of a programmer touching grass. It's amazing. And because you are running this completely on your own terms, there are zero strict paywalls or prompts limits. You type it and your code generates it, the whole shebang. So here's our quick roadmap for today. Building your AI generator, the easy path with Google Colab, the heavy hardware dilemma, the hardcore path of a local setup, running the Python code, and finally, how to keep learning and building. All right, let's kick things off with section 1, building your AI generator. Basically, this sets up a sort of choose-your-own-adventure scenario based on whatever computer you happen to be using right now. You've got two distinct methods here. Method 1 is the cloud route, using Google Colab. This is entirely free, it requires zero complex installation, and honestly, it's absolutely perfect if you're working on a slower laptop or a machine without a dedicated graphics card. Then you have method 2, which is the local route. Now this runs directly on your machine, giving you ultimate control, but fair warning, it is incredibly demanding and definitely requires a modern, powerful GPU. Moving right along to section 2, the easy path, using Google Colab. Okay, so this cloud process is wonderfully streamlined into just 4 steps. First, you start by opening up a pre-configured Google Colab notebook provided by the creator. Then, and guys, this part is absolutely vital, you need to change the runtime settings. You have to make sure it's set to Python 3, and you must select the T4 GPU option. Seriously, if you leave it on CPU, it's going to take an absolute eternity. But once you're connected to Google's free T4 GPU, you just click Run on the first cell to install all the necessary dependencies for the Stable Diffusion model. Finally, input your prompt in the next cell and hit Run. Boom. That's literally it. You are officially coding an AI generator in the cloud. In the source demonstration, the creator used a super simple prompt, a house in front of an ocean, and they just adjusted the width and height parameters directly right there in the code. Now, a quick heads up for when you try this yourself. The very first time you hit run, it's definitely going to take a bit longer. The code actually has to download the model dependencies into that cloud environment. But the good news? Once that initial download is cached, every single subsequent image you generate, whether you just tweak the prompt a little or change it completely, will process in just a few seconds. Pretty neat, right?
Which brings us to section 3, the heavy hardware dilemma.
So why not just run everything locally? Well, if you decide to use a cutting-edge model like Stable Diffusion 3.5 Large, you'll literally need to download a massive 16 to 17 gigabytes directly to your hard drive, and that's just for the model itself. You see, these models are incredibly sophisticated. They're packed with parameters that allow them to understand complex lighting, intricate textures, and really nuanced prompts. But as you can guess, all that sophistication comes with a very heavy storage footprint. And get this, storage is really only half the battle here. It takes about 1.5 minutes to generate a single image using that heavy 3.5 large model. And wait for it, that's running on an RTX 4090. That is literally one of the most powerful, expensive consumer graphics cards money can buy today. If you actually tried running this exact same high-quality model locally on a standard computer CPU, you'd be sitting there waiting like 20 to 30 minutes for just one single image. No way. This perfectly illustrates exactly why that cloud method we just talked about is a total lifesaver for older machines. All right, for the brave souls out there, section 4, the hardcore path, setting things up locally. Let's look at how we build this environment layer by layer. It's kind of like building a giant puzzle. First, you're going to need an account on Hugging Face. That's essentially the central hub for open source AI, and you have to formally accept their license agreement to actually use the models. Second, you got to prep your machine. You'll install Python, a code editor like VS Code, and this is crucial, if you're on Windows or Linux with an NVIDIA card, you need the NVIDIA CUDA toolkit. That's so your GPU can actually talk to the AI. Third, you'll clone the specific project repository from GitHub to get all the base code. And finally, you'll pop open your terminal to create and activate a Python virtual environment. Basically, this just creates a safe, isolated little bubble on your computer so all these new AI packages don't go messing with your main system files. So once that protective bubble is activated, you just finish up the setup. You'll run a quick command to install a list of base dependencies from a text file. Then, and the creator stresses this highly, so pay attention, you install PyTorch after the other dependencies. PyTorch is essentially the machine learning framework that makes all the magic happen, right? Installing it last just ensures your system pulls the exact right version for your specific operating system and GPU. After that, you hop back over to your Hugging Face account, generate a private access token, and run a quick login command in your terminal. This just gives your script the proper authorization to pull down those massive models we talked about earlier.
Okay, section 5, running the Python code.
Now, when you finally open up the Python script to run it, you'll notice a variable in there called inference steps. Think of this as your master control dial. It represents a very direct trade-off. If you dial down the inference steps, the AI is going to spit out an image much faster, but the visual quality is definitely going to take a hit. On the flip side, if you crank those steps up, the AI takes more time to really refine the image, giving you a stunning, high-quality result. But, you know, you're going to have to wait for it. The cool part is you can tweak this directly in the Python code to find the absolute perfect balance for whatever hardware you're running. And there is actually a pretty stark contrast between the two different scripts you can run locally. I mean, you can see a massive performance gap right here. The 3.5 model yields these stunning, high-quality results, like our programmer touching grass from earlier, but it takes a full minute and a half on an elite GPU. Meanwhile, the older 2.1 model, it can blast out an image in just 3 seconds on that exact same hardware. I mean, sure, it's lower quality, but it completely proves that you can still run local AI incredibly fast if you're willing to just scale down the model a bit.
And finally, section 6, keep learning and building.
To really take this further, the creator highly recommends shifting into a mindset of active problem solving using platforms like Brilliant.org, because honestly, you don't master Python and AI by just staring at code and memorizing syntax. You master it by learning the why through first principles. Interactive, hands-on problem solving is actually proven to be like 6 times more effective than just passively watching lectures. By diving into these bite-sized daily lessons crafted by educators from places like MIT and Google, you really train your brain to think critically. That's what bridges the gap between just following some online instructions and becoming a genuine software engineer. So here's the absolute crucial takeaway from all of this. You now have the exact blueprint to build a completely free Python AI image generator, whether you do it in the cloud or natively right on your own hardware. You've seen the code, you understand the big hardware trade-offs, and you know exactly how to dial in the performance to match your setup. So, now that you have the actual tools to run massive AI models natively on your own machine, what wild ideas are you gonna build next? Seriously, get creative, start coding, and just let your imagination run absolutely wild. Thanks so much for joining me on this explainer, and hey, happy building!